Guess what just happened? The Hubble telescope captured something mind-blowing. A live supernova event. Can you believe it? We have just witnessed the birth and explosion of a star right before our eyes. But how did the Hubble telescope manage to capture such a rare and breathtaking event? Are we on the brink of discovering something groundbreaking about the vast expanse of space? Want to know more about this spectacle? Stay tuned for exclusive footage that will make you question the mysteries of the universe. I recently saw an image shared by NASA on their Instagram handle, and it left me struck. NASA regularly treats space enthusiasts like me to mesmerizing glimpses of our universe. The image that caught my attention this time is a true masterpiece, captured by NASA's Hubble Space Telescope. A snowman nestled approximately 6,000 light-years away from our home planet. Curiosity immediately sparked within me. How can a telescope situated far away in space capture such detailed and breathtaking images? In their recent post, NASA described the image as an emission nebula, a term that might sound complex at first, but the explanation reveals the enchanting science behind it. These nebulae are essentially diffuse clouds of gas, but what makes them truly fascinating is the way they light up. What causes these celestial wonders to glow? According to NASA, it all comes down to the energy emitted by nearby massive stars. These stars are charging the surrounding gas clouds with their energy. The process is called ionization, where the radiation from these massive stars strips electrons from the hydrogen atoms in the nebula. Now here's where the magic happens. As these energized electrons return to a lower energy state, they emit light, causing the entire nebula to glow. This process happens in space, creating a celestial display that captivates the eyes and sparks the imagination. In the specific image captured by Hubble, there are 3 bright blue-white stars at the upper left, blending with reddish-brown, orange, and white swaths of glowing gas and dust. What caught my attention was NASA's description of the upper portions of this image loosely resembling a snowman adorned with a scarf and top hat. The telescope utilizes its wide-field camera 3, equipped with infrared sensitivity. This advanced technology enables scientists to study protostars, which are essentially newly formed stars. The goal of the study was to observe hydrogen ionized by ultraviolet light from these protostars, as well as the jets emitted by the stars and other unique features. The dark backdrop of the image is studded with countless sparkling stars, and the diffraction spikes add a touch of celestial magic, making the image even more beautiful. The fact that this snowman nebula exists 6,000 light-years away raises another set of questions. What other wonders lie beyond our reach, waiting to be discovered? How many more celestial snowmen and cosmic masterpieces are scattered throughout the cosmos? NASA's commitment to sharing these discoveries on platforms like Instagram opens up a gateway for people like me, ordinary individuals with a passion for space, to connect with the wonders of the universe. It's not just about distant stars and galaxies. It's about the beauty hidden in the details and the dedication and passion of these scientists, which contribute to our collective understanding of the cosmos. It's truly inspiring. These are stars in the making, going through the transformative process of birth. It's like witnessing the very essence of creation on a cosmic scale. The image not only showcases the beauty of the universe, but also highlights the interconnectedness of celestial phenomena. The energy from massive stars influences the surrounding nebula, creating a dance of light and color. It's incredible how a single image from NASA can evoke such a cascade of questions and reflections. The beauty of the cosmos is not just a visual feast. It invites us to explore, question, and marvel at the wonders of the universe. Each image shared by NASA is a doorway to knowledge and inspiration, sparking a sense of curiosity that transcends the boundaries of our everyday lives. Just when I thought I had seen the most inspiring astronomical images, the Hubble Space Telescope surprises us once again with a journey to a galaxy far, far away. Now, get ready for a place where things you can't even imagine become unbelievably real. The image released by NASA and the European Space Agency showcases IC 438, a spiral galaxy located a staggering 130 million light-years from Earth. Take a moment to let that sink in. 130 million light-years. It's in the constellation Lepus, aptly named the Hare, surrounded by more familiar celestial patterns like Orion and the Big Dipper. The Hubble photo serves a specific purpose: to study the aftermath of a supernova explosion that occurred in 2017, at least from our perspective here on Earth. I can't help but wonder, as you probably are right now, about the incredible journey of light spanning 130 million years to reach our eyes and telescopes. The photo doesn't capture the explosion itself, but it provides a glimpse into the consequences. Chris Evans, the project scientist for ESA's Hubble, shed light on the photo's importance. With Hubble's exceptional angular resolution at visible wavelengths, astronomers can meticulously examine the stars surrounding the supernova. This allows them to make educated estimates about the age and type of the star that met its explosive fate. It's a fascinating process, using the remnants of a cosmic explosion to piece together the story of celestial events. Let's take a moment to appreciate the collaborative efforts behind these cosmic revelations. The Hubble Space Telescope has been a storyteller since its launch. Its unique capabilities, especially in ultraviolet and optical wavelengths, offer us unparalleled views of the universe. Evans emphasizes how these capabilities continue to provide exciting new perspectives, expanding our understanding of the cosmos. It's worth noting that Lepus, the constellation hosting IC 438, is part of a celestial family recognized by the International Astronomical Union, IAU. Established in 1919, the IAU's mission revolves around promoting and safeguarding the science of astronomy through international cooperation. It's incredible to think that through the lens of Hubble, we not only witness the beauty of the universe but also contribute to the ongoing scientific mission of organizations like the IAU. I can't help but pose a question. Have you ever wondered about the stories each celestial image tells? Every unique picture taken across the universe reveals a new chapter of history waiting to be discovered and learned from. The Hubble's revelations, coupled with the advanced capabilities of instruments like the James Webb Space Telescope, propel us further into understanding astronomical phenomena. Speaking of the James Webb Space Telescope, it's worth acknowledging its powerful infrared capabilities, paired with Hubble's imaging and spectroscopy at shorter wavelengths. These instruments provide critical information needed to deepen our comprehension of cosmic events such as supernovae. The synergy between different telescopes, each contributing its unique strengths, showcases the collaborative spirit of the scientific community. Let's circle back to the photo of IC 438, the interplay of light and time and the profound questions it raises. How did the stars in this distant galaxy come to be? What forces shaped their existence? And what cataclysmic event led to the birth of the supernova? It's like reading a detective story where the clue is a piece of light from eons ago, guiding us through the mysteries of the universe. But the mysteries are still unsolved. If you were an astronomer peering through the lens of the Hubble Space Telescope, what stories would you uncover? What questions would you ask the stars? The universe, it seems, is an open book waiting for us to decipher its pages. So, which chapter are you most interested in? Let's have a chat in the comments below. But have you ever wondered how galaxies interact with each other? I'm talking about two immense cosmic entities, millions of light years away, locked in a gravitational embrace. This gravitational tango shapes the very essence of these galaxies, influencing their morphology, structure, and evolution over cosmic timescales. The Hubble Space Telescope becomes our lens in this drama as we gaze upon ARP 114, also known as the tadpole galaxies. We witness a slow-motion collision between two spiral galaxies, NGC 2445 and NGC 2444. It's a sight to behold. This choreography is destined to end in a fiery merger millions of years from now. But how can we experience this dance? Not just visually, but also through our auditory senses. Well, let me introduce sonification, a transformative process that converts astronomical data into sound. Just as we use imagery to visualize celestial objects, sonification allows us to perceive the cosmos through our auditory senses. In the case of ARP 114, the brightness of the celestial image is translated into sound volume. Brighter regions, indicative of intense star formation, produce louder tones. Conversely, dimmer areas, like the wispy tails of the galaxies, result in softer, more ethereal sounds. But there's more to the duet. The color data of the image controls the pitch of the sound. Blue regions, representing young and hot stars, produce higher pitch tones, while redder areas, signifying older and cooler stars, resonate with lower frequencies. This adds a layer of complexity, creating a musical tension between the exuberance of youth and the wisdom of age. Close your eyes and envision the sonification of ARP 114. The piece begins with a low, melancholic drone, echoing the vast emptiness of space. Then, as the focus shifts to the galaxies themselves, the music erupts into a swirling, chaotic dance of high and low tones, punctuated by bursts of brightness. It's a delicate yet powerful composition. Have you ever imagined the universe as a symphony, with galaxies playing their unique parts in this orchestra? From now on, the scale of our imagination will definitely be expanded. Beyond its aesthetic appeal, the sonification of astronomical data serves a scientific purpose. By converting complex data sets into audible forms, scientists gain additional perspectives on the underlying patterns and structures within the cosmos. The knowledge we can unlock by listening to the universe's secrets encoded in the melodies of ARP 114 is going to be very important to scientists. But one thing is worth mentioning. I didn't even imagine that things like this could be done. Kudos to the team behind this. Meanwhile, here comes the most interesting thing. The brightest fast radio burst, FRB, ever witnessed has just dazzled us, and it seems to have a connection with a bunch of ancient galaxies. Can you believe it? I certainly had to double-check my sources on this one. Our radio skies were lit up by an FRB that made all previous bursts look like mere sparks. First picked up by the Square Kilometre Array Pathfinder radio telescope in Western Australia, this burst got the scientific community buzzing. Now, fast radio bursts, FRBs, aren't exactly strangers to us. We detect them almost every day using our radio telescopes. These are fleeting cosmic explosions, short-lived but with the power to outshine an entire galaxy in just a fraction of a second. What makes this particular FRB so special is not just its luminosity but also its origin. See, the majority of these bursts usually come from single galaxies close to our own Milky Way, but this one had plans to break the mold. The curious minds behind this discovery decided to turn the gaze of the Hubble Space Telescope towards the source. What they found was very surprising. Not a single galaxy, but a group of ancient galaxies in the midst of a merger. I mean, who would have thought that these powerful bursts could be linked to a galactic meetup? The 7 galaxies playing a part in the spectacle are around 5 billion years old, which is more than a third of the age of the entire universe. Now, I'm not an astrophysicist, but it seems like our understanding of FRBs is about to get a major upgrade. Astronomer Alexa Gordon from Northwestern University in Illinois led the team that delved into this celestial mystery. According to her, it took the sharpness and sensitivity of the Hubble Space Telescope to pinpoint exactly where the FRB originated. Without it, we might still be scratching our heads, wondering if it came from a single galaxy or some kind of dynamic celestial dance. Kudos to Hubble for shining a light on these weird cosmic environments that are helping us unlock the secrets of FRBs. But we still don't know what causes FRBs. The scientific community has some theories, tossing around ideas involving massive and compact objects like black holes or neutron stars engaging in mergers. So, could the merger of these ancient galaxies be the key to understanding the mystery of FRBs? Are there other bizarre cosmic events waiting to be uncovered, each revealing a new layer of the universe's secrets? And what about the energy levels? For times more than any we've witnessed before. What powerhouses are at play here? I want your insights on this. Tell me what you think about it. Gordon believes that the quest for the origin of FRBs is far from over. The hope lies in the future, with the promise of more powerful radio telescopes set to come online later this decade. The Square Kilometre Array Telescope, currently under construction in Australia and South Africa, is one such instrument that holds the potential to revolutionize our understanding of the universe. Gordon says we just need to keep finding more of these FRBs, both nearby and far away, in all these different types of environments. But can we handle the mysteries that await us? Or will they continue to baffle us with their enigmatic brilliance? Well, let's hope for the best. But now, it seems we've finally witnessed the most beautiful language of the stars. A distant spiral galaxy, formerly known as NGC 941, is residing a staggering 55 million light-years away from our humble abode, Earth. This celestial entity, with its bright yet somewhat indistinct spiral arms, has recently unveiled its secrets through the lens of Hubble's advanced camera for surveys. What caught my attention is not just the galaxy itself, but a fascinating cosmic event that has been seen within its boundaries. A stellar explosion, commonly known as a supernova. This supernova goes by the name SN 2005 AD. A supernova is the grand finale in the life of a massive star. When these massive stars exhaust their nuclear fuel, they undergo a cataclysmic explosion that momentarily outshines the entire galaxy they inhabit. In the case of SN 2005 AD, its brilliant burst has faded away, leaving behind a legacy that paves the way for future star formation within NGC 941. An amateur astronomer named Koichi Itagaki played a very important role in this discovery. Yes, an amateur astronomer, not a seasoned professional with access to state-of-the-art telescopes like Hubble. It begs the question, how did an amateur astronomer manage to spot a supernova event before the professionals armed with powerful cosmic observatories? The answer lies in his skill, facilities, and perhaps a touch of cosmic luck. Supernovae are not subtle events. They announce their presence through sudden bursts of brightness in the night sky. They appear rapidly, brightening and dimming over a span of days or weeks. This swiftness makes them challenging to catch, but the vigilant eyes of amateur astronomers like Itagaki, who has discovered over 170 supernovae, prove indispensable. While the Hubble Space Telescope can collect an immense amount of data in just a few hours, the processing and analysis of this data can take weeks, months, or even years. But these space enthusiasts dedicate countless hours to monitoring the skies, scrutinizing Hubble's images, and uncovering astronomical events that might otherwise slip through the cracks. They bring a unique set of skills and a personal touch to their observations. Unlike their professional counterparts with specific tasks and limited observation time, amateur astronomers can spend more time gazing at the heavens. This increased dedication allows them to notice celestial phenomena that might elude the eyes of professionals. To facilitate collaboration between amateur and professional astronomers, a valuable tool called the Transient Name Server was established. This online system serves as a platform for reporting astronomical discoveries promptly. In the case of SN 2005 AD, Itagaki's timely report helped professional astronomers swing into action. They swiftly reported their findings through the Transient Name Server. The baton is then passed to the professionals, who conduct spectroscopic studies to confirm the nature of the event. In this case, it was a Type II supernova resulting from the rapid collapse of a massive star. Once the professionals had confirmed the supernova, the Hubble Space Telescope was directed toward NGC 941. Its advanced instruments, like the ACS, captured a breathtaking view of the galaxy, showcasing its spiral structure and the remnants of the stellar explosion. This collaboration between amateurs and professionals brings us closer to understanding the mysteries of the universe. There exists a rich library of previous supernovae, painstakingly built over time, which owes much to the keen eyes of amateur astronomers. Without their vigilant observations, many celestial events might slip through the cracks, depriving us of valuable insights into the cosmos. So, the next time you gaze at the night sky, think about the invisible threads that connect amateur astronomers, professionals, and the powerful gaze of the Hubble Space Telescope. Now one thing is clear. The universe is huge and full of amazing things, like stars, galaxies, and cosmic events. We've seen amazing pictures from the Hubble Space Telescope, from a snowman nebula to the aftermath of a star explosion in a faraway galaxy. Each picture tells a part of the story of space. We're at a point where we know some things but still have many questions. The universe is like a big stage, where stars are born, collide, and say goodbye. Our curiosity and teamwork between regular people and scientists keep pushing us to explore and find new things.